Welcome back to the Your Project Shepherd Construction Podcast. We teach here that every successful construction project has these 4 key components that are demonstrated by this simple drawing of a house. The foundation is proper planning. The left wall is your team. The right wall is communication, and the roof protecting it all is proper execution. Have all 4 of those components in your place, and your house will be rock solid. On today's episode, on this season rather, we've been talking about what do things cost, and we've been covering different components of building a house, the construction project, the design, all the components that influence the cost of your project. And today we are going to be talking about something that a lot of people are interested in, and some people will go down the road a little bit and explore it, but they never actually execute it because they're just so unsure of kind of how to do it properly, what it's going to cost. And that is solar panels and battery storage. And today with me to talk about that, I've got, again, I think for the 4th time on the show, Toner Kersting with Toner Home Matters. And also for the first time, we have Dana Hajedemos with Kima Consulting. Welcome, guys.
Thank you.
Hi, guys.
I'm so glad to have you guys. This is a topic I've been wanting to cover for a while. And honestly, this is something that I am very weak on. I always lean on Toner when it comes to this stuff. This is not my department, so I'm glad to have an expert and 2 experts, we'll say. We'll call Toner an expert for today.
Truly, sure.
He is an expert. So happy to have you guys talking about this. And I know that kind of like everything we've been talking about in this season with cost, this is a tough conversation to have because we don't know like how big of a house we're doing, how many panels we're doing, how many batteries, all that kind of stuff. But I do want to talk about what are those cost drivers? What influences the cost? And how to not overspend on something like this. I think if somebody goes straight to a solar panel company that they see ads for on Facebook or Instagram, they're going to sell them potentially something that they don't need. They're going to sell them a big system, a lot of panels, and it may not necessarily meet the needs of their house. So I also want to talk about, how do we plan this so that you're getting the kind of system that you need for your home. Toner, you've been working with Dana for a while. Why don't you start and just kind of introduce Dana a little bit and talk about how you guys started working together and how you do work together.
Sure. So Dana is probably one of those, I like to call her like a unicorn of the industry. You don't really know she's here. But we've been working together for over 6 years. So for a long time for us in the solar world, a 6-year relationship is like a 50-year marriage, right? Like that doesn't even exist. And on the way over here, we were talking through old stories, and I don't get to see Dana in person. She's in Austin, right? Very appropriate for you to be living in Austin and in this industry.
Represent.
Right. And, but so when we do get to see each other, almost all of our stories are about solar companies that have already gone out of business. So it's kind
Similar
of crazy.
Experiences, yeah. Having the same struggle.
So to have a relationship that's been this established for this long, that means a lot in the industry. In fact, out of all of the solar relationships company wise that we've had, Dana and I's relationship is most definitely the longest. So, and that's because she is and of course, please correct me on the actual term that you like to use, but you're a solar designer. And
that's it.
Yeah.
Mm-hmm.
And so why don't you give us a recap of what your business is, how long you've been doing it, and then also after that, get into where you just came from and how important that kind of stuff is.
Yeah, NABCEP's really important. We'll definitely get to that. I moved to Austin 10 years ago. I got a job at a solar company. I have some engineering background. I actually studied chemical engineering in undergrad. Worked for this solar company in a project management capacity, and then very quickly they realized, oh, this girl knows AutoCAD. She should be on our engineering and operations team. So I basically became the staff engineer at that company, and it lasted 3 years or so. I was mostly doing residential design work, a little bit of commercial. The company imploded, for lack of better terms.
Just being polite.
And while that was happening, they decided to get rid of their residential division and only be doing commercial work. And so some people who had been laid off from the company started their own install crews and started feeding me some residential work on the side. So I realized, oh, maybe I can do more than just be the staff engineer at this one company. Maybe I can be the engineer for a couple of companies. And so freelance solar Dana was born. That was in 2016. And Toner was one of the first clients that I had, again, through one of those connections from that company. So basically what I do as a solar designer is I create the plan set that details your module and inverter, so your solar equipment specifications, how it's going to get laid out on your roof, the electrical diagram for how it all gets wired together and connects to the grid via your breaker box or, whatever methods we're using, obviously dictated by building codes, electrical codes. It's kind of like we always say the bastard child of structural engineering, electrical engineering, and then, some applications thrown in. And then now, as the industry is moving towards the Internet of Things, of course, then we have all IT and smart devices also getting integrated batteries into these systems. But anyway, that's what I do. And now I have a small team doing that, building a small team at Kiva Consulting, which is wild to say. I'm super grateful for them. But we create plan sets so that your installers can take them and get the permits that they might need, get the interconnection applications with the utilities that they need. And then obviously the crews know what to build when they get on site.
So if somebody hires you, are they going straight to you? Are they going through Toner? Are they going through the installer? How does somebody come to work with you?
So the people who come to work with me are generally electrical contractors. I guess Toner is kind of an oddball in that sense.
He's a unicorn.
He's also a unicorn.
A room full of unicorns.
So much. And so, yeah, I don't interface with homeowners. I mean, maybe on a special crazy battery design where, it's a James Bond villain and we're, backing up who knows what's going on.
Yeah.
And you really need to get involved on a level to figure out what the motivations for the project are. But
And I think that's important. You are a B2B client, so you're a business to business. You're not out trying to see what your Google 5-star rating is, so homeowners will call you. But I like to think of Dana as the way that we do our business cards internally. So you can, what most people do is they call up and they say, hey, I want this business card in this color with that font. Please make it. I don't do that. We have a business card group out of Canada. And I call them up, and instead of telling them what I want, we tell them the personality and some of the things that our employees like. And then they send us a business card based on the design that they think is the best. And they're always 100 times better than what we would have chosen. So Dana, and at least with the model that we utilize, we don't give her those parameters. She gets to design that structure based on her infinite design experience and figure out what's going to be best for that system, right? We're not trying to match up to a utility program or an incentive program or anything. So I think when you let the talented designer do the design work, you're going to get the best result from that. And you've always been able to provide some really, really great solutions. And then we get the opportunities from value engineering and everything associated with that.
Yeah, thank you for saying that. It's nice to design that way, right? Like you're saying, people, I mean, it's no wonder it comes back better because there's more maybe joy, creativity in that process. Not that I don't find joy in my other solar designs, but it's very different when a contract just comes to you. Here's what was sold. I'm very disconnected from that process. Like I said, maybe in the future, or obviously for energy storage, it's important that I would be, or at least someone with that knowledge would be involved way earlier. But yeah, getting, basically a CAD file or, PDF of house plans, starting from there, creating something based on their true motivation for resiliency for their house. And you just look at it from a totally different perspective. It's not how much solar can we put on this house? It's what are we trying to accomplish here? I guess new construction is a little funky because the consumption and like usage patterns are a little unknown, but you've come up with something so creative to deal with that from the solar perspective. So we can talk a little bit about
Well, yeah, sure. And I think it's important to note that we're on a podcast that's about new construction and remodeling.
Right.
Not someone who has an existing home. And the way that we interact with Dana is we design for people, not houses. Because honestly, on a remodeled structure or a new construction home, I don't know what that energy load is. Even if I use all of the energy tools and software out there to anticipate with the load, they're always wrong,
Right.
especially in Houston and even in Austin and my other Dallas. With climate migration, those models never anticipated our number of cooling days in actuality and the amount of humidity we had to remove. So they're always
Even the
wrong.
cold weather,
The cold
weather days, big problem. Maybe
Yeah.
a bigger problem than the hot weather days, at least in Austin. And also, nobody anticipated the pandemic and the way that you're living your life at home changing, and that obviously directly impacts, that electric bill,
Most definitely.
the consumption rather behind the electric bill. First of all,
So before we
But-
get into some of those like particular designs, why don't you explain where you just came from and how much trouble you have to go through just to
That's
do what you
right.
do?
That's part of my background. Also, I will introduce y'all to NABCEP, which is a whopper of an acronym, the North American Board of Certified Energy Practitioners. They don't even say solar in there, and they really should, because it's by solar professionals for solar professionals. Just a standard for the industry, installation, design, operations, commissioning, maintenance of solar energy and now storage systems. So I had to study up for this pretty difficult test. Actually, I got my certification in 2014, which is
Old.
But
You're
yeah,
an old
I know.
fi-
Now
You're the
I'm
old trout.
I guess so. I like unicorn better.
I asked her today, I was like, is your number 82? Like, and of
But
course,
like true engineers, the numbering is complicated, and nobody can really figure out how I have the number that I have. But anyway, I spent this week doing continuing education at NABCEP, and it's really, it's cool to see new products coming out. That's always so much with solar, maybe with lots of industries. Code's constantly changing and getting updated. Technology coming online or, coming to the market that then pushes those codes to change and vice versa. But it's nice to remember that I'm not doing this in a vacuum, because as a freelance, just kind of solo designer for a lot of years, and now just with a small team, sometimes I forget that there's that whole industry out there. We did some sessions, super technical, digging into a lot of science behind the products, some vaguer or just more broad, rather, industry things, and then 6 whole hours of NEC code yesterday, which gets
That'll
a
put
little
you to
dry.
sleep.
It'll definitely put you to sleep. There were lots of dad jokes, to make sure we were paying attention. But it's necessary. Like I said, the codes change, and it's kind of a discussion with these moderators too, because everybody's having similar issues with their inspectors, with certain interpretations of things. All this to say, NABCEP gave me that confidence that I have that level of certification. I have, that organization and all this continuing ed just to always, further my career and provide the, good designs and good practices
And-
to my client.
that's not required.
Nope.
So there are
Certainly
plenty
not.
of people out there, and
Certainly
and
not.
I know there's solar providers and manufacturers that will say, hey, you want to be a solar company? Here's some software. I'll give it to you. And you can just use this to design. And ideally, that software is also designing for the sale of their product. And they've never done this before, and they don't go through this kind of training, right?
They don't have to. NABCEP, I'm trying to think if it still is required. I'm thinking incentive programs at local utilities. I mean, it's certainly not required for, anybody to have a NABCEP solar design for, to get your tax credit or anything like that. It was more for local incentive programs where the utility wants to make sure that the customer is getting, good value for what they're spending on their solar system by ensuring that there's a NABCEP person on staff at that company, essentially.
I think like any profession, anyone that pursues getting those extra certifications, designations, attends these kinds of non-required education events. That's the kind of person that you want working for you. You don't want the person that's out there like blowing it off or doing the bare minimum, or that's not required. I don't need that. Like, we want people who do to go the extra mile to learn more about their industry and to learn how to better perform their job.
That's exactly what it's about, and that was reiterated all week this week too, at this conference. Even in terms of the code, it's like the code is like how do I even say this? It's the code. We want to be doing better than the code, right? The code is the bare
The
minimum,
minimum,
so
yeah.
to speak. And so being around people this week who are really trying to up the game in those regards, design, installation, all of it was really cool.
Let's talk a little bit about kind of how we got to where we are today in the solar energy sector. I think for a lot of years, solar panel installations on houses were more meant just to offset your utility cost, and that's kind of how people looked at it. But now, at least with the stuff that Toner and I do, we're looking more at replacing maybe a natural gas backup generator and using battery storage as it's kind of a backup system for the home, in addition to maybe offsetting some grid cost. Can y'all talk about kind of what that history is, how that transition came about, and maybe how that technology in the batteries changing has made that more accessible to homeowners?
Let me kind of set that up,
Sure.
because this is something that I don't think we could have this conversation if it hadn't been for the longer term relationship I've had with Dana. Because I don't sell solar. I don't make any money if any of our clients buy the panels or batteries or anything. And it's amazing when we remove the economic burden from that, right? I don't care about the margins here. I don't care about the weird financing models or anything like that. I know that our clients, when they do a good remodel or a good new construction house, they're going to be outperforming everybody else, which is the absolute sweet spot for then adding on production or microgeneration production, whether it be wind. I've done biodiesel, I've done biomass, I've done all these kind of things before. Solar is the most consistent.
I once turned algae into jet fuel. True
So-
story. True story. A vial about this big.
So we can get into that, but this is really the sweet spot. And I tried to convey this to our owners, but especially out of Houston and with the increase in our storm activities across the United States, right? Natural disasters, number of days without power, generators, of course, there's a scampering for them. Every time we have a storm, everyone goes out and buys every natural gas generator, and a natural gas generator is really an asset. Let's say you have a whole house or even a partial house generator. It's not a $5,000 deal. It sits over in the corner of the yard. It takes gas line. It takes a concrete pad. And whenever the power goes out, you get to use it. Only when the power goes out. So when we designed for solar perpetuity, which is what we call it, I don't know if you even hear that very much in the market other than out of our stuff. That's my stuff.
Toner terms.
Yeah, toner terms, solar perpetuity. We're designing for that same spend. And we start typically with 2 batteries, and you locate those in all kinds of locations, generally in the garage, right?
Correct.
And then we can have a really, really small array. So I'm not chasing a ton of panels because we know that the batteries are there. Now, the 2 batteries it's an important key. I mean, as battery technology changes, and Dana, just part of that conference you went to was an expo, right? And they talk about all these different batteries. And so she's always bringing this information back to us and helping improve it. But at the end of the day, you can have, when the power goes out, I like to say 2 to 4 days of power ready to go. You can apply it across the whole house if you like. And I can speak from experience of my personal home. We've turned off the power to the house, ran out the batteries, and I've gone for 5.5 days with 2 teenagers, big pool, good size house in Houston, and I'm fine.
And you're on N-phase, correct?
I'm on N-phase batteries. Yep. Right. And that works really, really well. But when I'm not in the need for backup power,
you're still benefiting.
I'm benefiting. We're running 10 days out of the month off grid because I'm just running when the batteries are full, we're running them down. And then when we go on vacation and we're not using that, I get grid credits. So it's a microgeneration facility. It's off grid capability and it's backup power. And it costs me the same amount as a whole house natural gas generator. And there's almost no maintenance.
That's a big one.
So when we send you a design, you give us this hybrid version, this one that shows you what the city wants to see, which is how many panels can you actually fit on the roof?
Well, like what Curtis started us out with, I mean, that was solar design. It was, you have this home, how much energy it consumes on a monthly basis. I don't have insight into daily usage pattern, nighttime, daytime. When is the energy getting used? I mean, for traditional grid-tied solar, that maybe wasn't important because you're tied to the grid. And so no matter whether the kilowatt hour that the solar produces goes to your load or goes to the grid, you are theoretically being compensated fairly for that, which is changing. Um, but that was it. So you're looking at a year's worth of consumption, and I'm, doing a very back of the envelope calculation of, well, then a solar system of this size in, Houston, Texas will produce me that amount of energy. And then you're capturing that as offset. So energy that will now not show up on your bill, or as the production that you sent back to the grid, which will show up as a credit on your bill. And that was it.
And that was expensive. That was a ton of panels.
But it could be a ton of panels. You could run out of roof space.
It might not look good.
Definitely doesn't.
Well, I know you think all panels look good, right?
No, I don't even know if I would go that far. That's why we need, people designing solar roof tiles out there, because you want things to be beautiful and functional. And I fully believe that technology will take us there. But it pains me, some of the designs that I do, popping little tiny rectangles in every nook and cranny.
We still have you design that big one. Like, I like to show clients what it looks like, because the design for solar perpetuity is such a fraction of the panels that they appreciate where you came from, right? Now, the actual communication of that and the functionality, you can do a great design, and you work with lots of installers across the state. And the actuality of the installation, let's take a little bit of time to talk about that, because that's the execution arm of this, right?
Sure.
And so how many installers do you think that, first off, how many designs did you do last year?
Oh my gosh, that's a big number. The busy summer months, I think it was like 300 to 350. So per month, for the year, 2,000 designs.
Okay. I mean, there's not a whole lot of independent solar designers. There are a lot of people that do it internally.
Yeah, usually a solar company has, in-house everything, or at least design maybe more tied to sale, and then they sub out the actual installation. It's interesting to see how the industry is,
which I think is
changed.
Key, because if I'm a solar company and I profit from the number of panels being installed, why would I ever consider doing a design that might serve the client better, but reduce the number of devices that I make margin on?
That's a really good point. And just what kind of business are you running? What are you about? And that's
yep. And if you gave one of our solar perpetuity designs, they'd be like, yeah, no, thank you for this, Dana.
Meanwhile, these houses, like you said, because they're already designed, smarter consumption, smarter insulation, all the pieces, maybe you don't need to be producing as much energy as you would think for such a large house. And again, with the battery, being able to capture that extra solar that may go back to the grid, because in a certain scenario, you don't have a lot of load, you're not consuming. You're capturing that into your battery so you can use it later, use it at night, cycle it at night. That's how you're, saying you're off grid for however many days a month. That's, storage really adds that component, like that extra self-consumption, which makes the investment even more worthwhile, especially when, maybe you're not getting compensated fairly, like we're seeing some places in Texas for the kilowatt hours going back to the grid. Or certainly in other states. California is coming out with, net metering 3, which is going to be basically limiting export to, a third for backfeed. So all these crazy things that the utilities will concoct, but the storage solution is just the way of the future.
Explain how that's changing, because I hadn't heard that before. So are the utilities not paying as high a rates, or not paying in the same way as they used to?
Exactly. Yeah, exactly. So, in Austin, I like to use Austin as an example because they never did true net metering. They do what's called a value of solar tariff, which I don't know who gets to get together and sit around a table and decide every year or however often what the value of a solar kilowatt hour is. Right now, I think it's 9 point something cents. It was 11. It's changed. So they measure all of your solar production and then multiply that by that by that
Amount.
amount, and that's the credit that you get on your bill. Net metering would be more just like your meter spinning backwards. So they count how much kilowatt hour got sent, back to the utility, and they credit you whatever price you pay for a kilowatt hour. So that's true net metering. But yeah, I'm seeing PC, a utility in kind of hill country of Texas. They dropped, I think, by more than half. So for example, if you pay 10 cents a kilowatt hour, they're only going to give you 5 cents for any that you send back. And, those numbers aren't exact, but it was a drastic change. Or a market like Hawaii, where you can't send anything back to the grid at all. It's a zero export market. So, I mean, it literally runs the whole spectrum of options here for what utilities might
So what's the incentive?
offering.
It seems like the incentive for doing it is decreasing then, right? I mean, other than maybe the perpetuity side of things and the storage, but the net benefit to having the panels, it's like, I guess you're still saving the environment maybe by using less energy, but you're still paying, or you're not getting the cost benefit.
Right. Or install double, but like that doesn't make any sense, right?
Yeah.
I could install double the system size that I technically need because financially I need double to make that back. So like, again, what is that motivation? But the storage piece,
It's
like
huge.
I said, is huge.
And that's a really good caveat, because we discussed this. It was like one of the first things we talked about when you came in today is the more we can break the solar generation away from depending on the utility costs to develop ROI, the better, because we're never going to be able to control it. If it's a 10-year spread, if anyone can tell me exactly what that utility district is going to do for the next 10 years,
right, good luck.
Let's go to Vegas. Let's go. Right. So when you have batteries as your micro generation facility, it's there. It's yours. You get to choose what you want to do with it. If it does overflow and you get some grid credit, great. But that's why it's important to know, okay, hey, it's there. It's mine. I can do whatever I want with it. And you don't have to worry about the tariffs, because Austin is not a retail electric provider, or the grid net metering and retail electric spaces like in Houston. That's not part of the conversation anymore. It's a lot easier. But it also makes me very leery of that initial offer from a solar company that is depending on that, because how good are those numbers? They're not good at all. They're speculation at best.
How much is the price of electricity actually going to go up? I mean, you can see anywhere from 2 to 10% over 25 years in some of these proposals that I see. So exactly. What is that cash flow graph? Can we get like, a series of lines at a bunch of different assumptions? And that's just, part of smart consuming also.
And we get this question. It's actually the most common question we get from homeowners when we're discussing solar. And mind you, in our process, we always leave solar for the last part of the conversation, because everyone has questions about it. What we're talking about today, I guarantee there's going to be we'll probably get more questions about this one podcast than probably the one I was on earlier this week, right? So it is everyone's curious about it. I think people are excited about it, despite political connotation and all these things. The interesting thing is my best solar clients are oil and gas guys. Because they understand energy, right? They know it. And actually, the higher up in the C-suite, the more they buy and the more they want to do this. But I'm trying to remember the track I was going with this. Sorry, I got excited about that, talking about oil and gas guys buying solar at a very high rate.
Love to hear that. Love to hear that. I mean, the costs have come down. Storage is expensive. I mean, it varies widely. What are we backing up? How long do we want it backed up? So many considerations, right? So it varies from expensive to extremely expensive. But that's going to change too. Those costs are, PV costs have come down drastically. The same thing will happen for storage. Maybe they're even seeing on just utility scale too. Yeah. Costs, right? Grid parity is happening more and more and more. Right?
I'm glad that we talked about that today. But, is that the equivalent to the weatherman goes and buys a tornado shelter? Does he know something we don't know? Right? Like, what is that? But,
what's grid parity?
Go ahead, Dane.
Pretend I'm dumb, because I am. Go ahead.
How do we explain grid parity? So, cost of solar energy versus cost of energy from, fossil fuel sources. When does that become the same?
we're waiting.
When does that become the same? And depending on where you are, I mean, in some places it's already happened. You hear about stories in Europe where Germany is like 200% solar powered on certain days because of all of the, renewable generation that they have. So just concepts around cost being equal.
Yes. And just like Austin has a higher rate of grid parity because they have nuclear power that is really, really inexpensive per kilowatt versus, some other production. So that's really getting into some weeds, but that is the goal. The grid parity is the goal, is that solar becomes equal or less in terms of cost for production than fossil fuels.
Right.
And once we hit that, that's why folks enter this market thinking this is the future, because it quite frankly is the future, right? Where we're seeing the biggest version of grid parity every day is in the electric versus gas vehicles, right? We're starting to see, what would we want to call that, vehicle parity? It sounds like a bad comedy show, right? I don't know what that is. So,
sir, are you talking about residential systems installed on houses parity, or are you talking about like large solar farm
I was
parity?
talking more on a utility scale when I used that term.
Okay.
What came to my mind, though, in terms of, for your house, it's like, okay, well, my electricity costs this. In Texas, still pretty cheap. My parents in Connecticut, 2.5x what we pay here. But if you're looking at your solar proposal, then too, everybody is, well, in the install world too, price per watt, right? That's the power rating of the system. But what you really should be looking at is how much energy is this thing going to produce over 25 years, which you can model relatively easily. And so what's your price per kilowatt hour? Because then you can figure out kind of your own grid parity, if you will, for your house. There's that assumption of how much your electricity cost is going to actually increase over however many years that you're doing your calculation. But that's how you figure out.
Does a residential system last
your own grid
for 25 years? Is it a 20? I mean, is there some decline of performance over the lifetime of the system? Is it going to maintain the same output?
I wish I brought some module spec sheets with me. Right on the front of most module spec sheets will show you the performance, decline curve, basically. And what do they guarantee? After 25 years, still 80% production, if not higher. And that's standard, if you will. Module manufacturers warranty the equipment for 25 years. Hopefully you got a new roof before you get solar, and your roof lasts about that long too.
Not in Houston, unless you do a metal roof.
Also true. Houston, what a difficult place to do. What a fun place to do.
That's right. That's very fun here. I think the warranties are absolutely hilarious with solar groups, with solar products and solar companies, because I don't know any that's been around for 25 years.
Not quite yet. That's the bankability, right? I mean, huge players entering, exiting all the time. We used to install nothing and design with nothing but LG solar panels. You've heard of LG, right? Everything, every appliance in your home. And they exited the solar market last year.
Wow.
So, right, you can't predict it.
So what do we do with all of the LG batteries that we designed? And obviously someone's going to pick it up.
Yes.
But that brings us to...
I think they rebranded from LG Chem to LG Energy.
And they weren't bad batteries at all.
Well, everybody now is hot on the lithium kind of like thermal overheating issues, and the batteries start blowing up. But the good news there is the lithium ion phosphate batteries are very safe.
So I'll tell you basically, because you just let the flaming cat out of the bag.
Someone had to do it. That's all I've been hearing about all week.
We hear
UL
about
9540.
We hear about the safety of these things, right? Like, I mean, everyone kind of tries to tell me, well, I had a lithium battery phone that caught fire, right? Like, because what was the Samsung phone that had a battery that did heat up and some did catch fire. We have a jurisdiction here, and if you're installing a lithium battery, you're not allowed to attach it to the home per fire code. Okay, I can understand that, because when it does catch fire, it's the sun melting on the side of your house. It is not a
There's
campfire.
Oxygen in there. It will just keep
going.
Oh.
So their rule was you cannot attach it to the home. Understood. But you're welcome to put it on a 4x4 post 4 inches away from the home. So that's the safety.
That was the solution.
That's the solution. So obviously that fire marshal doesn't understand the intensity, but I always like to point towards the Prius, right? Some of the first introduction of lithium batteries on a commercial scale. They thought that originally they were going to be 8-year products and that would be dead, right? Like I remember reading an article, where are we going to store the Prius batteries? Like that was going to be a thing. And you know where we store them all? In cabs in India, because that's where every Prius goes after they're 20 years old. And there's still cabs everywhere.
Still running.
Right. And they're still running. And of course, there's disposal and all that kind of stuff. But I guarantee that you will have a dishwasher catch a house on fire way before the lithium battery does. And dishwashers are not even regulated to the point that lithium batteries are.
Yeah, absolutely.
So I'm not really necessarily concerned about that. I did want to kind of go back around to some of the pricing that's when the oil guys threw me off, is on ROI, right? Like that's the question I get all the time. What's the ROI on this? In fact, the proposals try to speak to most of the solar proposals will speak to ROI in them. But I would like to remind everyone that's listening to this podcast that has a house or is remodeling or building new, what's the ROI on that dishwasher? It's horrible. It's 100% going to get thrown away in less than 25 years. Almost everything that's forward of the sheetrock has a worse ROI than solar. It will not make you a single dime. Your countertops will be replaced, likely your cabinets, your flooring, your appliances, your lighting. Most of your paint will degrade. Most tree might keep some baseboards, maybe a door or two, but the vast majority of the house forward of the sheetrock has the worst ROI. If this solar system provides one penny, we've outperformed the vast majority of the products in the house.
I would say the argument there is that there's other things you're going to have in your house regardless, whereas the solar in today's market is still kind of an optional add-on. So people are evaluating it differently than they would the countertops or the dishwasher, whatever.
So let's talk about that. When is it required? What other states require solar right now on residential homes? Do you know?
I don't even know if I know the answer to that.
I
California.
California.
I mean, here required to be in the plans, right? It's required.
Solar ready, right?
Solar ready.
Should be solar ready.
In the city of Houston, you are required, and it's actually not a new requirement. It's been around since 2018. You have to pre-design a house for solar in order to be certified that you meet the energy code. And that requires 3 things. One is a homeowner certificate that shows the array in scale. It shows the consumption per panel. You've done hundreds of these for us, if not thousands. We turn that into the city. Then you also have to provide what's called the construction document, which shows the array, pre-wire, conduit size, location. And then the energy certifier has to inspect it. Now, there's a couple ways to pencil whip your way through that. I don't recommend it. But that's why I can say every house, I would say not every, 90% of all the houses that we've done since 2018 are fully pre-wired for solar. Yeah. So, and those are, I would say 99% have been your designs. So we're really happy with that.
And you say so city code, is there some so it's a
City of Houston code.
It's just City of Houston mandating.
There was a requirement that all jurisdictions had to evaluate the adoption of a solar design or option. So all of them should have it in their planning periods when they're going to implement either design or require installation. The good thing about a city implementing design is it can delay for a long period of time the requirement for installation, versus other states where they didn't require design. They just jumped to straight installation. Where that's more of a California rule. Colorado has a similar rule, some other states, and then it can be refined all the way down to this small city. So there's a couple small suburbs in Dallas that require actual installation of a solar device, but that solar device can be a solar attic fan.
I see.
So they get kind of pencil whippy with
solar heating for your pool.
That's right.
What can you do if somebody's like, I want to do solar in the future, but not today when I build a house? What things can be done today to make life easier in the future, both on the design side and on the construction side? The kind of the bare minimum that the city makes us do is we've got a tube going from the electrical panel to the peak of the roof.
That's it.
I don't know if that is that really enough. Is there something else that should be done?
It's pretty simple. I mean, because with Toner, we kind of have this approach of, okay, let's do 2 batteries and a limited amount of solar, and then get a picture of the consumption and then reevaluate. But even if you're not doing that, if you're not installing yet and you're going to install in 2 years, the inverter technology is going to be different, theoretically, the modules, the wattages. So we've allotted space on your roof, but today the modules are 350 and in 2 years, watts, I'm saying, and then in 2 years, they're 400. So now the wire sizes might not, they might not necessarily need to be different. But my point is you're still leaving it a little open-ended for install. And that's why it is as simple as, piping conduit for the wires that will go from here to here. Maybe you're going to do storage and you weren't going to do storage before. And so, all the math that has to get done to figure out, the, fusing and whatever pieces of your system, interconnection points, that it just could change. So it's like, why are you going to do all of that design at this stage when you haven't actually made all those decisions yet? So it's easy. Just keep it simple.
And I would say that we're also trying to reserve space on the roof, right? So I don't have a plumbing stack pop up right where the panels are going to go. We build these wonderful envelopes, and I don't want to have some solar guy pop up who wasn't part of the original team 3 years from now and inadvertently pop a hole through the envelope and not seal it properly, especially when we get into garages, right? We have fire codes based on those garages. So I need that. I'd like to have the conduit there in place. I like to have the pre-wiring there in place, ready to go, so we can preserve all of the auxiliary things. No more leaks on the roof, penetrations through the envelope, moisture introductions, violation of the of the fire envelope. That's a safer play. I had a project where they installed 2 batteries. I won't say the manufacturer because they're so huge they'd probably come down and rain fire on me. But it was a retro house, actually not far from here. It's Bel Air house. Detached garage. So you have a detached garage, you have the big 2-story house, and there's normally a little covered breezeway. And that covered breezeway is normally where all the electrical home runs run through. So that's why they installed it there, because that's where the panel was. But that had it was just after a remodel. They decided to do it really, really late. Well, there was a firewall that was built between that at that breezeway. And that's a really important place to build one. And in fact, they retroed it because of the fire risk. Well, the solar installer, when he's running his conduit, didn't want to run conduit over the roof. And I appreciate that. I wish he had run it along the edge of the soffit. He went right through that and he broke out and he used a claw saw. Do you know what a claw saw is? It's the back of a hammer. So
it has a name?
Yeah, it's called a claw saw. So it's a huge hole. Ran his conduit, which went all the way in and then up the side of the house. And they actually went through the roof from the underside, which is always a fun thing to try to repair. So all well and good. Well, they had a vehicle fire. And because of that conduit run, all the fire went up, followed that hole through the firewall, through the breezeway, and torched the house. So had we done all of that, or had all of that been designed and performed during the remodel, it would have been sealed properly. We would have had the proper fire blocking, and we wouldn't have been there. So, yeah.
And what's the cost to do that?
I mean, nothing.
It's that conduit's nothing.
Nothing.
It's nothing. Somebody's time for.
It's like one of the cheapest things that you can install in a house. That plastic conduit, the Smurf tube or whatever.
Yeah, and it's the same as speaker pre-wire. I mean, we both started in the industry where every house you sold, it's pre-wired for speakers, and no one ever installed the speakers, right? So if you do this and you decide not to put in solar, that's fine. But you can say, and you can sell your house, that this house is literally and figuratively pre-wired for solar. And you can show the stub outs. You can show sometimes. I have some clients, some builders that put very distinct labeling there. They reserve the space on the panels and everything. And that's a selling option. They can't get more money, but it may help the house sell faster. So I think that's a key benefit.
So beyond just the minimum of running the conduit from the panel to the roof, it's also smart to run to a future battery location, maybe in the garage. Correct. So not just the one conduit, run 2 conduits. It's $40 worth of conduit instead of $20 worth of conduit.
Exactly.
Right. And then just the aesthetics for later, not having to dig through.
Yeah, you're not having to cut holes in drywall and everything else.
You don't follow me on social media, do you?
I do.
Excuse
me.
You don't have to.
Of course I do.
Okay, it's a slow-moving train wreck. But I love to take pictures of conduit strewn solar installs just across these roofs and down the side of the house. And I had one the other day that dropped off the fascia. Instead of coming back to the side of the house, they just kept it 8 inches off the house and dropped it 2 stories. I was like, that was beautiful. That's so ugly and nasty.
That's so unfortunate.
Yeah. So, and we would hopefully never see that from any of our installs, especially because hopefully it's already pre-done.
Hopefully everybody's NABCEP certified and they know to do better.
You've got it. That was a good bring back. And we discussed this morning. I feel sorry for I actually feel sorry for our clients that bought systems 6-7 years ago. What is the difference between panel production when you started and panel production now?
I was thinking about that this week. I think when I first started, we were doing like 240 watt panels.
Yeah.
And now we're doing 400s 10 years later.
So almost twice the production per panel.
Some improvements to efficiency.
Yeah.
Without having to do like a bifacial or, some crazy manufacturer who has a different patent and a copper backplate or something.
You said one of my favorite solar terms, the bifacial panel.
I mean, they are pretty.
They are pretty.
They are pretty.
Why don't you explain to everyone what a bifacial panel is?
Explain to me, because I've never heard that.
So normal modules, they just have the back sheet. So it's basically the light penetrating the solar cell just in one direction. But when you're bifacial, then it can reflect back. So it's like they're see-through. So it's 2 layers of glass. And so you're getting like double photon penetration.
And what that technology and their testing didn't take into account for is the increase in the solar reflective index quality of roofing per the energy code. So our roofs actually, based on energy code, were required to have a certain amount of reflectivity of heat and light and UV. So that's the SRI. So the new energy codes require a higher SRI, which is actually making those panels perform even greater than they anticipated.
So better investment then.
Yeah.
I mean, they are more expensive, obviously, but
Speaking of investment, let's kind of move into the cost side of things. For a typical is a terrible term, I think, but for a typical home that wants here, we're in Houston, so let's talk about Houston, that wants a battery backup, 2 batteries, a small array to achieve solar perpetuity. What's somebody going to spend on average on a system like that? And this may be a better question for Toner, because you said you don't get too much into the cost side of things.
No, it would be. I'm interested to hear what he says. I mean, PV alone, what do you figure? $350 a watt?
Yeah.
6 kW system? I mean, maybe even say 10 just for ease.
What we're doing is I don't care about the solar cost. I care about the natural gas generator cost, because that's the bucket I'm pulling from. We're not creating a new bucket of money for solar. We're just taking from the natural gas bucket that was sitting there. So
everyone wants a natural gas generator in their new construction.
And how much? So you tell me, Curtis,
what was that?
What's
number?
that cost?
It depends on the size of the house. But on the low side, 15,000. On the high side, 35, 40,000.
Okay, yeah, I was gonna say a 24 kW Generac, $12,000.
Yeah, before
install and all of the maintenance and add-ons and everything. It's let's say $20,000 out the door on something like that, maybe.
We like to tell people that a good natural gas generator, depending on the size, is going to be $20,000 to $40,000. The average solar perpetuity, that's going to be 2 batteries, 4 to 8 panels, depending on the production of the panel type, brand, manufacturer, bifacial or not. I have a bifacial job we're doing right now. It's really awesome. We were able to cut the panels down by 60%. Yeah, and fit it onto this really cool 1930s cubist project. It's really awesome. Yeah, it's awesome. And lay them flat, all this white roof it, all this kind of stuff. They just let me go nutty on it.
Energy production can be beautiful.
It can be beautiful. So, but on an average house, and we just finished one up in the Woodlands, Texas, just an average production builder house. It was probably like a DR Horton or something. That install was $32,000. Now, so let's say it's $20,000 to $40,000. That's before incentives. I never ever speak about the incentives, because I don't guarantee that any of that's going to be there. And I want this decision to make sense without them. So incentives for me are just barbecue, and that's it. So if you do $38,000 on 8 panels, 2 batteries, you can run off the grid a couple days out of the month. You can get grid credits, microgeneration facility, and you get 2 to 4 days of power on your whole house. You spent that money, but you got $12,000 back. That's great. That's just icing.
What kind of incentives are there currently here in 2023?
The federal investment tax credit, 30%. It was coming down in steps until the IRA
Mhm.
went through at the end of last year.
30% of the cost of the
30%
system.
of the top line cost of your energy
Yeah.
storage system.
And is that panels and battery combined?
Correct.
And labor, materials, the whole shooting match?
Correct. Top
Yep.
line.
And
top
what we
line
do is
contract cost.
we even back in our design costs into that. So you'll get paid back 30% of the design costs, which are a fraction. And so it's that's a good incentive.
So $30,000 system, $9,000 back, right? Is my math,
Yep. No, you got it.
my public school
So-
math working?
So for $21,000, can you go buy a natural gas generator that's going to give you more than just a couple days a year whenever the power goes out?
That might even not start when you need it.
That makes noise.
Yeah.
I mean, we do have neighborhoods here in Houston that no longer allow natural gas
Yeah,
generators.
Noise, exhaust.
Yep.
Yeah.
yeah, when
yeah.
the thing kicks on and the whole neighborhood's got them, it's like,
Yeah.
just this ambient noise just increases. You can't sleep.
A power outage. What I also want to point out is the batteries. There's no downtime, so the grid goes down and your loads stay powered.
Mhm.
It's so it's less than milliseconds, right? It's very quick to change over. Whereas a generator, your loads are going to go down and have to repower in 30 seconds.
Yeah.
Generally.
The batteries actually know the
Um,
power is going out before you do because
Correct.
it senses the grid
Correct.
depletion
frequency.
first. Yeah,
Yeah.
the frequency. And
Oh,
yeah.
wow.
It
Frequency
clicks over.
voltage. Yeah.
Yep.
Inverters are very smart.
have we talked about how cool they look in a garage? Like,
You've showed me some actually.
yeah, they look awesome. It looks like you compressed kit and stuck them on the wall. It's like they are good looking spaces. And I had one battery manufacturer say, "Oh yeah, you can disconnect it and take it with you." It's like, I don't know if you're going to go through all that trouble.
They're so heavy.
They are super.
They're so heavy.
super
That's a 2-person job for sure.
So one thing I also wanted to touch on was, again, I see a lot of, I'm on social media all the time, on
I'm following
Instagram,
you too.
and
Oh.
Facebook. I'm constantly getting these solar company ads, and a lot of them talk about financing, like, get this at no cost up front because they're going to finance the cost of the panels and the install and all that stuff. What are those financing schemes? Schemes may not be the right word, or it might be, but how does that work? And is that a good or a bad situation? Because it seems to me like you're replacing your power bill with a payment to the solar company.
I don't disagree. And I also have limited experience with solar financing.
It's that type that I'll give you a real world example. On Galveston Island, there is a this really cute 1901 structure down in the historic district. It's been owned by the same family since 1901. And the woman who lives in it is very, very sweet. But she likes to, how do I say this? Collect a lot of things. But she's living in this home and she's on a very, very limited budget. And it's very expensive to be on a limited budget and live on Galveston Island because your insurance is like $16,000 a year just to live there, right? If you want to have insurance. If you own the house, you don't have to have insurance at all. So she's on a limited budget. So solar person comes up, knock, knock, knock. She's super happy to talk to anybody. They come in, they say, "Hey, can I see your electric bill?" She shows it to him. She's like, "Yeah, I live in Galveston Island, 1901 house. I have a $436 electric bill on average. And they say, "How would you like to not have an electric bill?" Well, that sounds great. Okay, awesome. We're going to put on this array, no batteries. I look across and because I can see her house from my house, and there are like 41 panels on the roof of this 1901 home. No conversion of rafters, no structural considerations, conduit running down the outside, everything. So now they're right. She doesn't have a $430 electric bill. She has a $430 bill to the solar company. And when she sells that house, it comes due. And it's spread out over 30 years.
30 years.
Wow.
Most of the solar loans were
She's
10.
83. So her estate will be burdened with this bill. That's predatory, in my opinion. It's not okay. Now, that's not saying that all financing models, see, that's a good word, right? Financing models.
Yeah, it's better than schemes.
Aren't great. But we discussed this earlier when, 10 years ago, they tried to do solar leasing and how complicated that was to the real estate model. And Curtis can speak to this because he's a realtor. Also, how challenging it is when you sell a structure and sell a home and you tell a new buyer, hey, by the way, you got to pick up the remaining $18,000 on this solar bill. Right?
Yeah, no one's going to want to do that. No.
That happens all the time.
They'll be like, okay, well, give me a credit at closing
right.
to cover that, right?
That's right.
Or take that off the price or whatever, right?
So, and that's a real deal. And we're dealing with litigation behind that. It's actually the fastest growing part of our building performance litigation business are what we call abandoned sites. And they're related to solar failures, systems that aren't working as contracted, ones that are just dead in the water. And those are extremely complicated to diagnose and figure out what to do with it. And a lot of times they're just trying to get the solar company to be a good company. So we're actually more of a contractual issue than many of the physical solar installation issues.
I mean, like you see in a lot of construction stuff, it's like the classic overpromise and underdeliver. So I think that a lot of these solar installation companies and sales companies make big claims about what they're going to get you, and then people get really upset when they're not getting what they thought they were getting.
Right. And how quickly, timelines at utilities for interconnection applications, timelines for permitting. Yeah, it all can add up, in addition to maybe, companies needing business 101 so they can operate.
Yeah.
better.
I mean, solar companies are a contractor. They're a subcontractor when we hire them, but they're a contractor just like any other construction trade, plumbing, electrical, GC, whatever. So they have the same struggles that a lot of construction companies have, being a low barrier to entry to get into the business in general, here in Texas, at least.
Most definitely. And I encourage all my builders to not contract the solar, kind of like the whole, do you contract the pool or not? Right.
Right.
I recommend they don't. Let them be independent, because you could be finishing up 2 years of really high quality work and have the last solar install wreck that goodwill. Let them be independent. Their contracts are super specific, and trying to blend their contract through your contract makes it very difficult to interpret who's responsible for warranty. So I always recommend keep those two things separate.
I mean, there's a project that Toner and I are consulting on right now that we were talking about before we started recording, where a solar company here in town really overpromised the homeowner on what they could deliver. She came to this guy and said, I want to be able, if we get a hurricane and our power's out for 2 weeks, I want to be able to run my house for 2 weeks off batteries. And he said, oh yeah, sure, we can do that. And it's on a townhouse with maybe 800 square feet total of flat roof. And then you have to deduct the walkway around the perimeter of the roof on that situation. So now you've got maybe 500 square foot area to put enough panels to power 4 batteries, maybe, that she's not going to get what they told her she was going to get.
Yeah.
2 weeks. Yeah.
Well,
2 weeks of whole home backup.
Yeah.
How big is her wallet?
Well, she has a lot of batteries.
And she said, I want to run both 2 air conditioning units. I want to run both air conditioning units and my refrigerators, my freezer, and everything else for 2 weeks. Oh, sure, we can do that.
Yeah. So
should and could, or
that's right. And so they're doing a ton of batteries, but how long it's going to take, maybe 6 panels to charge 6 batteries. It's going to be
60
forever.
kilowatt hours.
Yeah.
Let me do some quick math. 1 panel is going to make you how many kilowatt hours in a day? Can I do math? Can I use a calculator?
You're welcome to use a calculator if you want. The only thing is the using the calculator doesn't translate on podcast very well, right? So you need to make sure you go click, 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 click as you're using but it's going to be a challenge.
You did that just as I was tapping on my phone and it alarmed me. All right. So let's assume a 385 watt panel in a year makes that many, in a day makes,
It's going to be a long time.
If you're filling, right. Are we really taking the batteries from 0 to 10 kilowatt hours each during that day? If you were, you would literally need, 60 modules to do that. So, but even, let's say, 30 modules.
I did back math on that, and
Yeah.
I said, here's the deal. If we can get them installed with those number of panels and give us 60 days of production, you're probably going to be close to full capacity. But then if you drain it, it's not going to be the same because I'm charging 60 days before they move in. So once they have other consumption, I can't tell the variables on weather. It's a minimum 60 to 90 days to charge all those batteries. But no one
That doesn't sound
conveyed
wrong. Yeah, that doesn't
that.
sound wrong. Which in maybe this application, not so much, but when you're thinking about true off-grid, grid independence with solar and batteries, a gas generator is like an integral component of also that whole system.
Mhm.
So that when you have that 2-week outage or, unpredictable weather, rain, and your batteries your battery bank does get depleted, you have a way to recharge it.
See, that's kind of where the ridicule from the oil and gas guys has come
Yeah.
in. It's like buying your all electric Ford Lightning pickup truck and having the generator sitting in the
Mhm.
bed to charge it.
Well, and we do have to remember that we were very, very close from during the 2 freezes ago of residential natural gas being shut off.
Mm-hmm.
So we just have not experienced that natural gas shut off yet. But Dana and I did a project over on Olympia, not very here in Houston, beautiful. And they have a really nice pool house that they're building, but then they have their original 7,000 square foot house up front. So Dana helped design that as a bug out house. In the event of a storm, that entire pool house is running and humming off of a 2 battery setup and 8 panels. They bought just the small enough natural gas generator for the main house to keep one AC going just to keep the dehumidifiers going. Not even AC. I don't care about AC. Screw that.
Right.
Just dehumidifiers and their refrigerators and stuff. So they would all leave. Everything's secure over there. And they move into the bug out house and they hang out there and they have a good time. But then we did a reverse switch so they can also take the natural gas generator and charge the battery with it if they wanted to. So yeah, that was a really, really cool house.
Last topic I want to touch on is solar roofs or solar roof panels, solar roof tiles,
Shingles, yeah.
solar shingles. Sorry. Yeah. So I've been seeing more of these. I think Tesla has theirs. There's some other manufacturers coming on the market for that. So let's talk about are those good? Are they worthwhile? I know nothing about this topic almost. So you guys take the solar panel shingle topic and run with it.
I have not designed one myself yet. I know less than a handful of contractors who did the Tesla program and I believe have installed some. The issue with Tesla, even like with their power walls, is talk about overpromising and under-delivering. You can never get their products supplied. So I'm disconnected from how the roof product is kind of going for them at the moment. I have seen schematics. It's elegant and beautiful, and the efficiency of the solar cells might be 2-3% less than a regular standard module. But when you can cover more surface area of your roof, that doesn't really matter.
I think it's
from
also
an area perspective.
just the aesthetics. So you're not seeing a large array of panels on top of your roof.
Right, you're not punching holes in roof, right? It just is. And also, they're rated for hail damage, just like a regular solar module. So they make a pretty resilient roof from what I understand.
They do. They're very architecturally significant, right? So they don't work on all styles of structures. It kind of reminds me of the 1980s Lifetime roof, right? That was this kind of square rectangle, a less relief, though. It's more of almost like resembling of a concrete tile that you would use on a more transitionally modern structure. So that's a little bit of a challenge to make it look good. I have seen a couple houses that have them and they don't need to have that style of roof, but you know what? The roof is super cool. We are on 2 projects where it has nothing to do with the production quality or the product itself, but there's a lot of excitement, especially around Tesla products.
Sure.
So we've had some guys that were probably not really ready to tackle this product that did, and now the site is abandoned. and we're trying to find someone to come on to do it, but the money's not there and the owners are hurt. And then we have another one where there's nothing wrong with the install. There's nothing wrong with the product, but the way they were sold, the end result was so poor to begin with that we're having to come in and we call that our busting bubbles. We're just popping everything you thought this was going to do. It is not going to do because your math was bad to begin with. And I'm the velvet hammer in that situation coming in, and we're the in between.
And those were both Teslas.
Both Teslas. Yeah. And once again, nothing wrong with the product whatsoever. One was installer problem. One was perception of sale. And we're having to navigate through both of those.
But new products, I mean, even with energy storage, all these batteries coming on the market. I mean, it's funny. I'll get some new technology that I've never seen come across my desk, and I'm the first person seeing that at this solar company. Somebody sold it. They didn't maybe understand, but then the crew has to go through also this very steep, quick learning curve to get that installed correctly. So it's like, wait a second, we're doing this all wrong here. Let's get trained for the products and then decide we're gonna, only sell those when we really know what we're doing and know what we're installing. But this industry has, just forced contractors into thinking that they have to behave this way when really they should lead and say, no, we're going to do the research first, learn first, maybe let the products go through several iterations to get the kinks out. I mean, we're having like Gen 3s of a lot of these batteries coming out. Powerwall's on 2, Enphase is coming up on 3, Panasonic's Evervolt is coming up on 3, and the list goes on. So they get more elegant. The teams, get more wise as to how the products work, how to work with them, what works well, what doesn't, what design scenarios and use cases should actually be applied. And then it's a better deal for everyone.
Well, I think we're about out of time for today's solar discussion. So I appreciate you being here, Dana and Toner. Always good to have you back as well.
Thanks for having me.
We'll definitely do this again in the future. We have some more. We have an episode planned next season about building technologies, and so I think there's some more discussions that can be had on this as we get into that. So,
absolutely.
So, and thank all of you for joining us today on the Your Project Shepherd podcast. We hope that you join us next time. We have 1 or 2 more episodes left on season 2, and then we'll probably have Toner back for our end of season wrap up, where he and I will kind of just give a quick synopsis of everything that we've talked about this season. So anyway, thank you so much for being with us, and we'll catch you next time.